Welcome to a new video in my home automation series, and today I'm going to work on some new stuff in Node-RED, and I'm definitely going to have a shorter version of that maybe a couple of weeks later, but I thought I'm just going to record the whole thing, how I create something from scratch. And what I'm going to do now is what you have seen previously is I created this project where I read a single phase energy meter, and that was for my charging station for the electric car. So that has been built. That was the previous video, and now I've tried to build a Node-RED flow to monitor it. So that's what I'm going to do today, and I only want to do the basics today. So I want to monitor the data coming in, and then based on the power consumption, just determine when the start and the end of the charging is, and calculate the kilowatt hours that got charged into the car, and then maybe send it on to Telegram, something like that. And of course, record the whole thing in InfluxDB. So, and I think there's going to be a few more things with this, EV monitoring or the charging monitoring. So I'm just going to create this new tab called EV, and probably is going to be a lot more stuff added to it. So let's start with some comments. So monitor energy consumption. Okay. And so the device is not running at the moment, so I just have to remember how it was all working. And I don't have any data, so actually I think what I'm going to do is I do have a couple of screenshots on the GitHub that I did already. So maybe I'm just going to look at that and see how it works, because I don't remember. Okay, so it was car charger / data. And I don't see the whole payload. Oh, do I see the whole payload? Oh, yeah, I was missing part of it. Okay, so I need an MQTT in, which is going to monitor car charger / data, and it's going to be my main Node-RED server, and I don't need any special quality of service. So car charger / data. Okay, fine. And I think I want a filter node. I'm thinking. So the reason I'm a little bit puzzled, because so if there is no charge, I don't really want to record any data, but the voltage is probably going to fluctuate enough, so so that is going to create some data. Actually, can I filter on? Oh, I can filter on power. Okay. Block unless value changes. Okay, so I'm going to do that. And I think I'm also going to further filter on not to have more than one message per minute, because I just don't want more information to be saved. Okay, so for all messages, 1 message per minute. Queue immediate, no, drop intermediate messages. Okay, so that would be 1 per minute, and then changes in power. Okay, and I want to save this in database, and I'm just going to pick I think I'm going to pick the me flora example. So save to DB, no, logging, not this one. I'm pretty sure that I'm saving this to InfluxDB. Okay, let's pick the GrowWhat example. No, I have to pick something else. No, I'm just trying to find an example so I don't have to do the whole flow from the beginning. Because I think the GrowWhat goes into a separate storage. No, then change of plans. So I also have a weather station. So I think I'm just, oh no. Weather station, it's this one. And I just need to find a place where I save everything into Influx. It should be here. Maybe you can tell that I haven't really done a lot of new Influx stuff for some time. Okay, I'm going to use this. So I think I'm going to use the sensor and yep, and then the value. So I'm going to say output dot push add sensor and car charger, and then so the measurement is sensors, the device is device, the car. Okay, really I'm getting a little bit rusty on this. How I did this? Okay, the fields. So I have a device. Okay, well, this is how I save a single device. But how do I do? So GrowWhat NFI is no 6 more. Zigbee and Shelly. Okay, so the measurement is car charger. No. The measurement is sensors. So the measurement is sensors, the device is car charger, and then I'm going to have voltage, current, power, and now I have to cheat. Okay, so active power, power factor, and frequency, and total active energy. So voltage, current, active power, power factor, frequency, total active energy. Total active energy. Okay, so I don't need that. I need a comma here, and that's just going to be the payload. Well, it's the same. The attribute name is going to be the same as the field name. Okay. Does it look good? Payload, current, active. So voltage, current, active power, power factor, payload, frequency, and total active energy. And then it goes to the thing, and I'm hoping it goes to the Node-RED bucket. Yeah, that's what I want. Okay, convert influx. Okay, that looks good. So this will save a value every minute when the power changes, and actually I need to change this to active power. Active power. Okay, so once the charger disconnects and it's just constantly reading 0 watts, then it's just not going to log anything in the database, which is good. New one. Actually, I want this information because otherwise, okay, I can live with 1 data per minute, so that's going to be fine. So it's going to monitor whenever so that's just going to save the data into the database. I will probably use this information for to build some chart, but I would need more data just than that. Okay, and also I think I'm going to push some of this information onto my touch panel as well, which has the energy monitoring screen. Okay, and the other thing I want to do is I want to be able to somehow tell when the charging starts. So, and I think what I'm going to do is I'm going to monitor the power factor, the power consumption. So let's say I'm going to okay, so I think what I'm going to do is anything beyond 10 watts means that it is charging. Okay, let and I'm going to store this in a flow variable. Flow.get charge state, and if charge state equals undefined. So that we handle the cases when this flow runs for the first time. So charge state equals, and I think I'm going to use some sort of object. So that's going to be an empty object for the time being. Charging equals false. So that's probably going to be something that I want to save. Okay. And now I'm going to monitor. So if charge state point charging, so if it's not charging and message.payload.active power greater than equal. Can I use this in JavaScript? I think I can. So if it's bigger than the power threshold, then that's when the charging starts. And also I think I'm going to update the context. So flow.set charge state. Oops. And I think I'm just going to keep it in the memory. Okay, so it's going to be the flow variable. Okay, and then charging starts is true. Charge state dot start equals new date get time. So let's also store the timestamp when it started. And also I want to, so let's call it start time. And I also want to store charge state dot start energy equals message dot payload total active energy. So that's the current meter reading when it starts. So total active energy. Okay, do I need to do anything else? Oops, my camera is pointing. Oops, no, it's better. So I think, so I say when the charging started, what was the energy that it started at. Probably going to be good enough. So node point status, and we are going to do a green ring and a text which says charging. Sounds good. If and I think probably what we gonna want to do is, oh, okay, we want to save this information, definitely, and return, and we are going to return the charge state because it has changed to charging. Okay, so now let's do the other way around. So when we finish charging, so if the charge state is charging and the payload active power is less than the power threshold, then we do the opposite. Okay, so this is false, and We have an end time, and we have an end energy. And let's say we change this to gray, and it says not charging. And other than these two statuses, we are not going to return anything. Okay. And I think at this point I want to send out a message. So service. So for this I'm going to set up one of my services. So I have this whole subscription model. Okay, that's not the example that I was looking for. So monitor schedule. Okay, it's not this one. What was the last one that I did? Oh, I think I done with the Shelly. Yeah. So okay, so these are the convert things, and then okay, that's the yeah, I want this piece. Well, it's going to be a lot of information for that, but okay, I'm going to use this, and oh, yeah, I needed the link out node as well. I just don't want to find it again. So what was that, Shelly? Okay, so this goes to the Telegram service dispatcher, so that should be fine. I think, yeah, either goes the same way, the same place, I guess. Okay. Send charge report. Okay, by the way, there is one more thing I want to do here, is charge state dot energy used equals why not? So that's going to measure in kilowatt hours. Okay. And out of all this, I actually only need this part. So the message.payload is okay. I'm not even going to use this much. I don't need the update. So it's going to be a new service, and for that I'm going to create that service. I've shown this in such a long time ago, but I'm using this ever since that video was made. So it's part of the Telegram thing. So I have these services. So the last one is 22. That's the Zigbee notification. So I'm going to create a new service. So it's just called EV. So that's going to be 23, I think. This slider is pretty bad because it speeds up so much. Okay, it's 23, it's triggered, it's active, access level, whatever. Okay, so, yeah. I think the events here is, sorry, how Oh, Jesus. So the way I store this information is I think when the field value changes, after some time, it sends this information out. It stores it in a context, and if I'm moving too quickly, then it just doesn't do anything. But now it's oh. So these are one of the things that I should really fix, but it's not a big enough annoyance for me to fix it. You see, it doesn't even update properly. New service. Okay. So let's move it back to 23 again. Whatever. So I want to subscribe to this service. I'm going to change the name somehow. The thing is, this is something that is still saved in a text file. So yeah. So it's not something that I stored in the database. But okay, I'm subscribed to this new service. I'm going to rename this at some point. But so that's service 23. So now I can reference to it. So that's going to be service 23. And the message is so charging completed. Energy used. Message.payload. I think it was called energy used. Used and plus kilowatt hours. Energy used. Okay. Okay, and the other thing I started doing is I always use a special icon for every single message. It's just much easier for me to tell where, what is the message that is coming, because even in the even if I don't see the complete message or if I don't read it, I can see the icon and I can easily tell what is it related to. So let me, I don't know if there is any better way to find out the code for these emojis. So I think what I'm just going to do is I'm going to enable this this one here, and I'm just going to send myself an emoji message. I just need to find it in Telegram. So go home, and I'm going to send myself. Okay, so how do I send? Not a photo, but I want to send a message. So I can't do it on my main phone because that's the one which is recording. So I'm trying to do it on my iPhone, and I have no idea how to send emojis because it shows me all the stickers, but I don't want a sticker. I want emoji, or one of the emoji icons. I guess I need to find this out offline once I finish recording. Anyway, that's just going to be an extra letter in the beginning of the message. So let's just not do that right now. And actually, I wanted to add a switch note here. because obviously I want different message depending on whether the charging started or not. So, and yep, and this is message.payload.charge. What was the name of the property? I think it was called charging. Is this spelled like this one, or I'm missing an E? So if it's true, no. Okay, if it's true, then this, and then, well, if it's false, then the second one. So the second one says the charging completed, and then the first one is going to send, I think I'm going to send a message to myself, so at least I know when the charging started. Charging started. Okay, I think this is going to be good enough. Actually, I want to do one more thing, is I also want to handle the fact that the, let's say if the power is gone, I will consider that the charging to be off. So what I want to do is I want to monitor the messages, and I have this thing for the deer. So last update. Okay, I think I'm going to use this node. Okay, this is probably not coming from the ones that I just created. Not that we have any message at the moment. And so this was designed, well, this particular function node was designed so I can monitor device statuses. And I think I need to implement this whole thing for this. Okay, so that lives on the logs. So I have all these systems, and I need to create a new system. So that would be, I guess, 49. I think I started with 10 when this flow was created. No, probably 6 or 7. And now we have so many EV. Wonderful. The system ID is 49. And so when it is working, it's going to send me MQTT messages every, I think, like every 10 seconds or something like that. So let's say if I don't get a message for 60 seconds, then it's dead. So the power is gone. So I don't want to use spaces because I think this is going to be used in the in the global variable. So device status, okay. I thought I created something which is, anyway, that's going to be fine. So, okay, we are not going to have any of these, and well, in fact, I think I'm going to remove this because I don't need this battery thing. I just have to remember that I don't copy this flow or this function node if I create anything for which has a battery. Okay, so yeah. So this just monitors when the last update was received from this device, and yeah, and okay, so the device is now online, and then the system ID is this, and then if it's offline, then the device is not transmitting, and I'm just going to change the severity of this because to 0. Okay, I still have all the battery stuff here. I guess it's not going to hurt. Okay, so message.warning is true, and the message.state is, that's going to be 99. Okay, so I think what I'm going to do is I'm going to move this here as well. Oh, by the way, and since we are logging this, or we are creating this as a proper thing, I think I'm going to use this one as well, which immediately saves all this information into the logging part, like, you know, logs the data when the device goes online or offline. And it looks like I have some issues in the code because I deleted that stupid thing with for the battery. So I think I'm just going to put it back because it's if it doesn't find any data which is related to the battery, it's just not going to use it. Okay, so these two lines. Oh, actually, no. These two lines, and there was some other piece of code as well. Okay. Okay. And if the state equals 99, so if the device goes offline, I want to handle those cases if the device goes offline, because for me that would be the case when there is no more power, so that again the charging will stop. So if the state equals and the number 99, then I want to fabricate a message. So message.payload. Okay, so the problem with this is that I wouldn't know what the last, because what I was thinking is I'm going to send in a message which has a power 0, so then if it was charging, then it's just going to, well, it's going to notice that this charging has stopped, like as if the charging has stopped. But then I wouldn't know what the last power reading is. The total active energy. I think I have a solution for that. Okay, so voltage, okay. Active power equals 0. Actually, I'm not really, oh, okay. Frequency equals, let's just push all the information in case we would need it in the future. Power factor equals 0, and the total, what was it called? Total active energy. No, let's put it -1. Okay, I think this is how the data looks like. So I'm just going to feed this in. So every time the device goes to offline, then it's just going to add another message in. And I think we are going to last energy equals, we're just going to save it in the context. So last energy equals context.get last energy or 0 context.get. Okay, and if message.payload total active energy greater than 0, then we are going to save that. Context.set let's do it the other way. So if in the data the total active energy is -1, then we are going to override that with the last energy. And then of course if it's not 0, 1, then we are going to save it in last energy in the context. And that should handle the case where the car is charging and all of a sudden the power is gone, because at least we would have the last data that was updated, let's say 20 seconds ago. And they would be able to calculate the energy used. Charging and time, well, the time is the same, and the energy is this one, then it's going to calculate from start to end to start. And I think that would work. So it's very rudimentary at the moment, but we have a notification, we are going to save the data in the database, and we are we're monitoring the state, so if we would know if the power goes in and then comes back, and then if the power goes out for any reason, then at least we will capture the last energy used, and we're just going to notice that the charging is completed. And the reason I'm going to do that, because the ESP gets the power from the same phase as what goes into the charger. So again, if it loses power, then the ESP loses power as well. So it won't be able to send the last message saying that, oh, we don't have a power because, well, it wouldn't be able to communicate with Modbus anyway. But anyway, it would lose power immediately as well. And I mean, this looks good. Definitely, I want to add some stuff here for you know, the icon. I think I'm going to do that, and probably once the charge ended, I also want to. I mean, it would be nice to save that in the database as well, but I'm not really sure what would be the best format, because I can. Maybe I can just save how much was used at the point when the charging is completed. I suppose I don't really care when it started or ended. You know, once I look at the statistics, because I mean, all I really care is like, okay, how much I charged, how much energy I put into the car every single day, or every single charging session. I mean, of course, the idea is that I would get some additional information as well, like the distance traveled. So I would be able to compare, like, you know, consumption, that sort of stuff. But that's not happening at the moment. So I think all I can do is save this. But I think probably I would, you know, create a node out of this and then put that into Influx as well. Just save it in a different metric. Because that would be useful. I just need to figure out if I want to use a separate metric, like a separate, if I wanted to create a new measurement, not use the sensor measurement, but I could even use the sensor measurement, and I can just use the, you know, the device name as, again, the car charger, or probably something else. And then it would just have one metric which says energy used, and then it would just save a value, and the timestamp is going to be the timestamp when this flow determines that the charging is completed. But I think that's going to be the next time. So let's test this for a couple of days to make sure that it triggers all the events and the states correctly. And then, of course, make sure that the database logging works as well, and all the other logging works as well, because yeah, I just have to make sure that the basics are working. But I think that would be it. It's not really complicated, but I think that should work for the basics. So let's finish the recording here, and I would run this for a couple of days, and then, you know, once I enhanced with some of the additional details that I have in my mind, then probably I'm going to release a shorter version of this, which just talks about the, you know, sort of the end result. And for the time being, I think I'm not going to share this flow, but I guess you get the main, you know, idea behind this anyway. So I think it's getting late anyway, so that will be all for today. Thanks for watching, and hopefully see you in the next video.